perfect. So what is, here is your kind of precision and recall, like how many false negatives you have?
I'm sorry, I don't have still that information. The system is still running, so to
So
say.
based on the training set, would you, and you did some training and then testing and verification?
Yeah.
You have some.
I think in initial after 30, and now again on the top of this is really from the top of my head. So the first test run after 3 months was 89% with this architecture, 89% accuracy, so to say. And of course, this is not enough for really running the production. This is why we left the system trained, and it's still training actually to see all the examples.
If I may continue on that question, I obviously don't know your architecture well enough, but so you had positive, you had negative examples, those that passed and those that did not.
Correct.
Have you considered using a sort of anomaly detection approach where you just take the positive ones? And
Yeah.
see?
Yeah, we did. At the end, the problem was they wanted to see why, and in order to see why, you really, you need to take this so that you can analyze and try to give them an idea why. Because yes, we could detect an anomaly, but if they don't know how to repair it, what's bad with it, when they can reassemble it.
Yeah, but it's more expensive.
It's more expensive, exactly. You actually prolong the manufacturing cycle. So you were first.
So you did not have a lot of data. So did you use some transfer learning to?
No.
So you built it from scratch?
We had to build it from scratch because there was no. It was especially for this kind of shape. You see, it's a weird shape. You cannot find that. You can find a lot of networks that recognize cats, dogs. People, boots, everyday thing. But this is so specific, and that's actually the problem in manufacturing, typically industry, that you have very specific things. We can talk about the problems in manufacturing. There is actually we now experiment a lot with reinforcement learning because that has a promise to optimize many processes in manufacturing. But the problem is, with reinforcement learning, I cannot put a learning algorithm to learn on a real-world system. It will create a disaster, So the question is how I do it. I somehow need to simulate the behavior of the real system, and then all the issues start. Do I simulate it well? Do I have all the examples and so on?
The second part of the question is kind of related. It's which kind of data augmentation did you use?
And we didn't use in this case. As I said, we just let the network get certain precision because they have really the production run is very fast. So they really crunch a lot of products. So in a relatively short period of 3 months, we managed to gather enough data to reach certain level of precision, which was satisfactory to start putting this. So we didn't use any data augmentation. One would be to use the guns, to try to make the gun and make it generate the examples for it.
But I mean just quotation or stuff like that.
Well, this we did, as I said, at the beginning, where actually we eliminated these simple geometrical transformations through pre-processing the image.
Yes, these are really beautiful architecture and easy to see how it works. When you got 50% failure rate, then you don't have basically any kind of a glass frequency bias there, and then this kind of supervised learning approach works really well. Of course, if you would have very rare faults in the process and they would all be very unlike each other, then you would use anomaly detection approach. But here is
Here, this was as well it's a pretty high rate of failure, so you could actually replicate a lot of failures. But again, it's not precise because it happened, there is a lot of variation as well in the product, and it happened in a practical use many times that actually the network gave a false result.
Did you detect common patterns? Was it always so? Did the GraphCam always said this area of bottom half or something was the most common case that something that activated or contributed to the
Yeah,
development?
you could start seeing the patterns.
Yeah.
Let's say these filler discs are missing, or they are not aligned properly and stuff like that.
Okay. And was it something that is actually no, because I really like this with this GrabCam to actually visualize
Which part of
explain
the
which part of the picture contributed to the outcome. But was this something that, for example, the engineers or the people assembling it, they said, yeah, okay, that's the most common error that we make. Maybe we should pay more attention to that, and then the process improves.
This
like,
is exactly
dramatically.
what they did, because as I said, I mean, if you get in a heat map something like this, okay, yeah, something is a problem. But what is the problem? There we needed an engineer to really explain what the problem is, why, what actually the system noticed, because the system doesn't know. Just sort of statistically relates this area with the outcome. So that's the thing. Okay, any other question?
We can, otherwise we can do that at the end. I would say close the presentation first, okay?
Okay.
I like
Well,
it. It's beautiful.
it is actually closed. So.
Okay, now open for questions.
Maybe from a practical perspective, besides the cameras, what's the rest of the infrastructure? So, how much CPU, GPU, memory, whatever power you have there to overlook that process?
Actually, for inference, for running the system, it's really a normal machine. You don't even need a graphical card there. A
No?
GPU.
Okay.
I'm talking about the inference phase.
Yeah.
For training, of course, you do.
Yeah.
So for training, we now typically use Azure, and virtual machines in Azure to train.
Okay.
I don't know, you train reasonably well with already 6 graphical cards, which is the smallest instance. I mean, already 6 is quite a lot, but that's the smallest instance that exists on Azure.
And how do you label then for the people to say, watch out, this one was the one that we have, the color on the heat map?
That was actually still not implemented. This is now after analysis of the engineers. We need to sort of show the labels basically, and that layer is still not implemented. That would
Okay,
be
like
a
filter out automatically,
filter,
hey, these ones
exactly.
should go out and these ones stay in production.
Exactly.
Okay.
So this would be really to tell, to now transfer this heat map into an information, hey, it is
Sorted.
the filler disk,
Yeah.
which you need to put that way and not this way. This part is not implemented yet.
And which framework did you use?
TensorFlow.
I have a slightly different question concerning NDAs, because like the information that we just provided could provide a profit to other companies. They had to sign like many NDAs, so I can't disclose that kind of information. Like, why didn't that manufacturing company give you any NDA in order to
It's
not?
simple. This product is really, how should I say? It's not a competitive product. It's something that everybody here and there manufacture. It's how should I say? It's yeah, it's a commodity product. So it's not something highly confidential that you could do. And here more was it's even not the loss of material that they had. There is another aspect of the loss which we didn't evaluate in the money terms, and this is they really have this scrap which is silicone and so on, and you pay a lot of money in Switzerland to recycle that. So that was a big part of the cost. So it was more like an environmental thing than really being very competitive on the market and so on. They actually look at other things to become more competitive than this. So yeah, I guess it's a commodity product. So that's why.
And also, let's be honest, many companies that go super high confidentiality, they kind of overdo it.
Yeah,
In the software industry, it's a little crazy. Like, oh, I'm going to show you my 3 boxes of designs. That's confidential. Give me a break.
No, and here actually, I mean, despite that I showed the principles, it's not I mean, you can try to replicate it. It's not so easy.
Exactly.
With your power at home.
That's a good argument too.
It's not so easy. I mean,
You cannot download it from GitHub, right?
No,
The production line.
on that sense, you cannot. So it's, and there is also this assembly with cameras, which I didn't show. So it's not easily replicable, so to say. You wanted to ask something?
Just one more. Are there other parameters that affect this? For example, lighting and so on. So if you don't, will it affect if you don't have a constant lighting condition?
Probably yes. Probably yes. We solved that problem by creating really a how should I say, a device with cameras, with light and so on to try to eliminate the influence of shadows and stuff like that.
But what if this light loses, for example, either the temperature or the intensity over a period of time when it starts aging? So you don't have the same.
I don't know. You are now asking me. Yeah, I mean, that could be a problem in the future. At the moment, I cannot say what will be the result. It can happen, let's say, we start detecting a lot of false positive, false negatives, and that the solution for that is to replace the light bulb. Yeah.
I mean, you can do the same, it's just really a computer vision model which predicts life
The light bulb.
of a lamp and exchanges when it's ready.
Yeah, but the industry is really interesting. That's I mean, first of all, just wanted to say about this. You see a lot of these examples in, I would say, in marketing, in art, in medicine, where there is a lot of effort at the moment in using AI, and you see really many things getting solved there. In industry, it's really at the beginnings, you know, and there are many industries which are even not digitalized. You need first to solve the problem of how you move the data into the digital domain to start using AI. There are so many industries, so these problems are very interesting as well, engineering problems. You really need to engineer the whole system until you come to use of the machine learning. And that aspect actually is very interesting, and this is where we try to sort of shine the light. Hey, you know, you cannot just apply machine learning on any data. Even if you collect a mass of data, which usually happens in the industry, it's totally unlabeled. You cannot use it, basically. So we are trying to raise as well the awareness in the industry that it's not enough just to measure. You need to measure in a sort of smart way or with a goal in your mind.
Let me just add to that. I have a feeling, because I was in smart grids or academia working on smart grids, I had a problem to get the data from smart grids as well. And I think a major problem there is also people won't just let you like that install something there and play with it, because the consequences are much higher than in marketing or in art. You can play freely in a virtual world, but when you get into industry, actually there are consequences if you make mistakes.
And this is exactly what I mentioned with this reinforcement learning, because I could see, for example, reinforcement learning in energy management. Imagine now that we have this building here, and we create an AI system where we give it the control of lights, heating, everything, you know. And through reinforcement learning, it actually, instead of minimizing the error function of the networking, minimizes the energy consumption. So we measure, this would be super. But who will give the building, you know, because at the beginning it will look comical, you know, you would have flashing lights all over the place, you would have heating going up, down, up, down. You cannot afford that. So somehow we need to, and that's the problem, and that's something that actually I would like maybe to open a discussion in this forum, how we can solve it, how to emulate this kind of industrial facilities so that we can train AI on this. And then how do you go from training really to production, how you deploy it and so on. I know of one successful application, for example, for energy management of the reinforcement learning, and this is Google, of course. They applied it on their data center. Very successful. 30% energy reduction.
But no humans to disturb there, so
Yeah,
that's
exactly.
good. Yeah,
Yeah.
that works.
So it works obviously, but at the moment the problem is how do you deploy it? So that's something to think about.
I think that's what I think it's a nice suggestion. We could work as a group on that as well. Like we said, working the paper, like industry would like to have the following quotation.